Voltage impact of rooftop solar photovoltaic systems on low voltage network and measures of mitigation. Considering solar PV on low voltage network, with the initiation of distributed generation, the traditional unidirectional power flow has now become bidirectional, in turn making consumers into prosumers. Among many power quality issues arisen due to solar PV, voltage rise and voltage unbalance are given a key consideration in our project. As of IEC 61000-430 Class A standard, a voltage rise of plus 6% from the nominal voltage and a voltage unbalance factor of 2% is allowed. The main objective was to implement a method to maximize the total hosting capacity by varying power factor and apparent power within the specified limits, such that overvoltage and voltage unbalance conditions are satisfied. An offline solution which caters both customer and utility requirements was developed. To model the distribution line, OpenDSS was used as the load flow simulator, while MATLAB was used to perform the mathematical optimization in order to obtain the maximum hosting capacity. As of considering the developed model, two types of inputs are fed into it. The line data consisting of load distribution and PV positions are given to the load flow simulator to model the distribution line. The input boundaries are then fed to MATLAB to undergo interior point optimization. As the optimization algorithm continues, apparent power and power factor values are fed from MATLAB to the load flow simulator, and thereby corresponding pole voltages and line currents are fed back to MATLAB. This procedure would continue till the active power is maximized within the predefined boundaries and the relevant apparent power and power factor values are given as outputs. A user-friendly interface was developed to make the process of feeding the inputs and obtaining the output results convenient. Using the input data and save, we can input the constraints, transformer details and line details through an Excel sheet. As well, details of the load set, apparent power ratings and power factors of the already existing PV panels, and the lower and upper limits of apparent powers and power factors of the newly connected ones that are yet to be optimized are given as inputs. The fed inputs can be optimized using the Optimize button. Voltages and line currents would output the relevant variation plots of line voltages and currents for all the three phases. With the aid of solar panel details, variation of power factors of the already existing and newly fixed PV panels of all three phases and three-phase PV panels can be obtained. The solution gained through the process, consisting of optimal values corresponding to apparent powers and power factors of the respective PV panels, can be thus obtained through an Excel sheet. As well, the total maximum hosting capacity is 2 given as an output. The main conclusions arrived through this project are: maximizing the active power of newly connected PVs, maintaining the power factor at unity on a line with already existing ones where their allocated capacities remain fixed. Connecting new PV panels to align with already existing ones and maximizing the total active power delivered by the newly connected PVs by manipulating both the active and reactive powers that can be delivered by each of the PVs. For the existing ones, if needed, only the power factor is to be manipulated while the apparent power already allocated is not changed. Handling both customer and utility requirements, providing the optimal solution while maximizing the total hosting capacity, satisfying over voltage and voltage unbalance conditions.